In this video, let us use a magical hexagon in solving trigonometric problems. Now let us solve example 9 of the chapter trigonometry. Express ratios cos A, tan A and secant A in terms of sin A. Now let us have magical hexagon with the 6 trigonometric ratios. Now we have to express cos A in terms of sin A. Where is cos A? This one is cos A, this one is sin A. How can we create a relationship between sin A and cos A? We know that if we move in clockwise direction along this triangle, we can get one identity. Start from here, sin square A plus cos square A is equal to 1. So now we have sin square A plus cos square A is equal to 1. We have to express cos A in terms of sin A. So move sin square A to RHS. So cos square A is equal to 1 minus sin square A. But we have to express cos A. So now let us take square root of cos square A, that is cos A is equal to square root of 1 minus sin square A. So this is the answer to the problem. Cos A is equal to square root of 1 minus sin square A. Now let us express tan A in terms of sin A. Where is tan A? This one is tan A, this one is sin A. How can we express our relationship between tan A and sin A? We know that if we move along this side, we can get an identity. Okay, tan A is equal to sin A over cos A. Now we can express cos A in terms of sin A. We have already expressed it. In the answer, we should have only tan A, sin A, and 1. We should not have any causes. But in our previous problem, we have find out that cos A is equal to square root of 1 minus sin square A. So now let us put 1 minus sin square A instead of cos A. So tan A is equal to sin A over square root of 1 minus sin square A. This is the answer. Now let us express secant A in terms of sin A. Where is secant A? Where is sin A? What is the relationship between secant A and sin A? No, we don't have any direct relationship. But we know the relationship between cos A and sin A. We can write sin A in terms of cos A. So secant A is equal to 1 over cos A. Isn't it? We know it in their reciprocal relationship. Cos A is equal to square root of 1 minus sin square A. So now let us substitute square root of 1 minus sin square A instead of cos A. So secant A is equal to 1 over square root of 1 minus sin square A. It is the answer. Now let us solve the first question of exercise 8.3. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Now let us solve. Let us have magical hexagon with the 6 trigonometric ratios. It is not compulsory. If you forget all the formulae, then you can use it. That's all. It is only rough work. Now let us express sin A in terms of cot A. Where is sin A in the magical hexagon? This is sin A, this is cot A. There is no direct relationship between cot A and sin A or sin A and cot A, isn't it? But there is a relationship between sin A and cosecant A as they are reciprocal ratios. And there is also a relationship between cot A and cosecant A. If we have a triangle like this, if you move from top left to right in the clockwise direction, we will have the identity. Cosecant square A is equal to 1 plus cot square A, or 1 plus cot square A is equal to cosecant square A. As we told earlier, the sin A and cosecant A are reciprocal ratios. So we can write like this: sin A is equal to 1 by cosecant A. All these are rough work. You need not write it in exam book. Okay. So now sin A is equal to 1 upon cosecant A. Now let us change cosecant A into 1 plus cot square A. So now let us square on RHS. 1 upon cosecant square A. 1 square is 1 upon cosecant square A. Since we have squared on RHS, now let us take square root of it. Sin A is equal to, what happens? Square root of 1 is 1. Square root of cosecant square A is equal to 1 plus cot square A. So sin A is equal to square root of 1 upon 1 plus cot square A. Square root of 1 is 1 upon square root of 1 plus cot square A. This is the answer. Now let us express secant A in terms of cot A. Where is secant A? This one is secant A, this one is cot A. There is no direct relationship between secant A and cot A. But we can express cot A in terms of tan A. Why? Tan A, secant A and 1 form triangles, isn't it? Now let us start from the top left, that is tan. So tan square A plus 1 is equal to secant square A, or secant square A is equal to 1 plus tan square A. Now we can express tan in terms of cot, isn't it? Because we want the answer in cot ratio. So we know that tan and cot are reciprocal ratios. Tan A is equal to 1 by cot A. All these are rough works. We need not scribble it in your exam book. Okay. Now we have secant square A is equal to 1 plus tan square A. Now let us convert tan square A into 1 over cot square A. What is the LCM of 1 and 1 over cot square A? It is cot square A. So secant square A is equal to, LCM is cot square A. In the numerator, cot square A plus 1. Since we have to express secant A in terms of cot A, let us take square root on both sides. So secant A is equal to square root of cot square A plus 1 over cot square A. So secant A is equal to square root of cot square A plus 1 upon cot A, because we can take the square root of the denominator, which is cot A. So secant A is equal to square root of cot square A plus 1 over cot A. This is the answer. Now let us express tan A in terms of cot A. Tan A and cot A are reciprocal ratios. Very easy problem. So tan A is equal to 1 over cot A. This is the solution. Now let us solve the second question of the exercise 8.3. What is the question? Write all the other trigonometric ratios of angle A in terms of secant A. Now let us have a magical hexagon like this. We have to express other ratios except from secant A. In terms of secant A, by observing the hexagon, we can say that secant A and cos A are reciprocal ratios. So now we can express cos A in terms of secant A. Where is cos A? This one is cos A, this one is secant A. So cos A is equal to 1 over secant A. This is the solution. Now let us express sin A in terms of secant A. This is sin A, this is secant A. We can express cos A in terms of secant A. Why? They are reciprocal ratios. So cos A is equal to 1 over secant A. And there is a triangular relationship between sin A and cos A. If we start from the top left and move to right and down, we'll get an identity. What is that? Sin square A plus cos square A is equal to 1, or cos square A plus sin square A is equal to 1, both are same. So now we have cos square A plus sin square A is equal to 1. Now let us convert cos square A into secant square A, since we are needed to write only secant, sin and 1. So cos square A is equal to 1 over secant square A plus sin square A is equal to 1. Sin square A is equal to 1 minus 1 over secant square A. What is the LCM of 1 minus 1 over secant square A? That is secant square A. In the numerator, secant square A minus 1. Both are in square form. Now let us take square root on both sides. If we take square root of LHS, we'll get sin A. Then secant square A minus 1 over secant square A square root of. Put square root for this one. So sin A is equal to square root of secant square A minus 1 over secant square A. Sin A is equal to, in the numerator, square root of secant square A minus 1. In the denominator, we can take square root of secant square A, that is secant A. So the answer is square root of secant square A minus 1 over secant A. This is the solution. Now let us express tan A in terms of secant A. We can have a Pythagorean identity between tan A and secant A. So let us have a triangle. Start from the top left to right, then down in clockwise direction. So tan square A plus 1 is equal to secant square A, or 1 plus tan square A is equal to secant square A. Now move 1 to LHS. What will you get? Tan square A is equal to, no, not LHS, RHS. Secant square A minus 1. Take square root on both sides. You will get tan A is equal to square root of secant square A minus 1. This is the solution. Now let us express cot A in terms of secant A. We know that tan A and cot A are reciprocal ratios. So cot A is equal to 1 over tan A. Tan A is equal to square root of secant square A minus 1. Tan A is equal to square root of secant square A minus 1. So cot A is equal to 1 over tan A. We know it. Instead of tan A, put square root of secant A square A minus 1. This is the solution. Now let us express secant A, cosecant A in terms of secant A. We know that cosecant A and sin A are reciprocal ratios. So cosecant A is equal to 1 over sin A. Sin A is equal to what? Square root of secant square A minus 1 over secant A. So cosecant A is 1 over sin A. So instead of sin A, let us write square root of secant square A minus 1 upon secant A. So cosecant A is equal to secant A upon square root of secant square A minus 1. This is the solution.